Shocking discovery. Aliens are doing this to black holes. For centuries, humans have gazed up and wondered if we are alone in the universe. In 1960, physicist Freeman Dyson changed the conversation by suggesting some cool celestial tech that would allow us to detect signs of alien civilizations more easily. So what is this tech, and how would it help us find aliens in modern day? Let's find out. Welcome to Space World. In today's video, we are going to talk about a shocking discovery according to which aliens are doing something strange to black holes. So if you want to know more about it, then stay with us until the end of the video. So far, no one has found evidence of intelligent aliens elsewhere in the cosmos. But according to a study, if they do exist, they might be hanging out on Dyson spheres, circling the husks of sun-like stars called white dwarfs, scattered throughout the Milky Way. And that's where we should be focusing our search for extraterrestrials. Study co-author Ben Zuckerman, an emeritus professor of physics and astronomy at the University of California, Los Angeles, stated, based on what that search turns up, astronomers could estimate how many advanced civilizations lurk in the galaxy. But how is this possible? Well, let's begin with some basic concepts of life. Any advanced civilization needs energy for food, for transport, for conflict, for comfort, and for convenience. Currently, Earth's 7.8 billion people use about 580 million joules of energy every year, equivalent to the energy output of almost 14,000 million tons of oil, according to the World Counts. Indeed, almost all human energy comes from fossil fuels, as we lack the technological savvy to rely on the largest generator of energy in the solar system, the Sun. So, if humans covered every square inch of Earth's surface with solar panels, that would generate more than 10 to the 17th power joules of energy per second. That would still be losing the majority of energy radiated by the Sun, about 10 to the 26th power joules per second. This is the motivation behind Dyson spheres, named for the famed physicist Freeman Dyson, who developed the idea in 1960. According to Freeman, if an advanced civilization really wants to harness the awesome, energetic output of their home star, they have to build megastructures to capture it, blacking out at least some of the star's light and converting that energy into other useful things. Dyson's original proposal of a solid sphere doesn't work because of stability issues, as it would be impossible to keep the star at the center and the entire sphere would disintegrate due to extreme tidal and rotational stresses. Even so, it's easy to imagine an advanced species building rings or swarms of giant solar panel-covered structures to get the job done. But no matter how advanced a species is, and how many Dyson sphere-like objects they build, they will have to contend with the fact that every star has a finite lifetime. If a civilization arose around a typical sun-like star, then someday that star will turn into a red giant and leave behind a cool white dwarf. That process will in turn roast its solar system's inner planets, and, as the white dwarf cools off, freeze the outer ones. So, staying put on the surface of a planet is not a viable long-term option. That means any aliens could either pack up and leave, finding a new system to call home, or build a series of habitats that harvest the radiation from the remaining white dwarf. According to a new paper written by Zuckerman for publication in the journal Monthly Notices of the Royal Astronomical Society, it seems unlikely that an alien civilization would choose to go through the trouble of traveling to a new star just to build a Dyson sphere. Thus, they're only going to build these megastructures around their home stars, which will eventually turn into white dwarfs. This allows scientists to make a direct connection between stellar lifetimes and the prevalence of Dyson spheres. So Zuckerman reasoned if astronomers look for Dyson spheres around white dwarfs and come up empty, that can help estimate how many advanced civilizations may exist in the galaxy. Here's how the logic works. Astronomers have only measured a small fraction of all the white dwarfs in the galaxy. But if enough aliens decided to build Dyson spheres around their white dwarf homes, then we should see at least one Dyson sphere in our surveys. If we don't see any at all, then that sets an upper limit on the number of alien civilizations building Dyson spheres around white dwarfs. Of course, there could be aliens who decide not to build Dyson spheres, or aliens that build spheres around other kinds of stars. But Zuckerman argues that over the age of the Milky Way, the most likely outcome of advanced civilizations is to build a Dyson sphere around their white dwarf, and so we should focus our searches in that direction. However, this search won't be easy. If any Dyson spheres do exist, they will likely be hard to find because there are so many stars that must be searched, Zuckerman noted, adding that the signal from the Dyson sphere will likely be very faint compared to the star about which it orbits. Now, adding to this, the presence of a Dyson sphere around a white dwarf will have two effects. If it's large enough or close enough to the star, it will block the light arriving to Earth just as transitioning exoplanets do. But such a Dyson sphere might also add a signal from infrared radiation. The megastructures will absorb radiation from the white dwarf and convert that energy into other things. Since no conversion is 100% efficient, this process will leave behind some waste heat that will escape as infrared light. Surprisingly, we have already found many white dwarfs with excess infrared emission. But that is due to dust in those systems, not megastructures, according to the research paper. Moreover, existing surveys of white dwarfs have found no evidence of any Dyson spheres. Given the total number of white dwarfs that we expect to inhabit the Milky Way, Zuckerman estimates that no more than 3% of habitable planets around sun-like stars give rise to a civilization that chooses to build a Dyson sphere around the resulting white dwarf. However, there are so many planets around sun-like stars that this calculation only provides an upper limit of 9 million potential white dwarf sphere-building civilizations in the Milky Way, the researchers concluded. In the end, though, nobody knows how many advanced civilizations may live in the Milky Way, if any at all, Zuckerman says. Some astronomers, including me, think that technological life may be a very rare occurrence, Zuckerman said. Indeed, we might even possess the most advanced technology in our Milky Way galaxy, but no one knows, so it is worth searching for evidence. Now, according to another theory, scientists believe that aliens could be sucking power from black holes, and that could be how we'd spot the extraterrestrials. This energy-harvesting technology could leave traces just outside a spinning black hole's event horizon, the boundary beyond which a black hole's gravity becomes too strong for matter and energy to escape. And the process could explain at least some flares of plasma, a white-hot form of charged gas that scientists have already detected near these massive disruptions in space and time. And while it's only a science fiction idea at the moment, the nearest black hole to us is thought to be more than 1,000 light-years away, which is too far to be reached in many human lifetimes. If astrophysicists could ever work out a method of tapping these cosmic behemoths, rotating black holes could become a near limitless source of energy for a technologically advanced civilization. But how does this work? According to astrophysicist Luca Commisso of Columbia University in New York, the plasmas for extracting energy from a spinning black hole are created by magnetic reconnection events, where intense magnetic field lines tangle, break, and rejoin just outside its event horizon. Magnetic reconnections are commonly seen on the surfaces of stars like our Sun, where they release tremendous amounts of energy as plasma flares that move in diametrically opposite directions, Commisso said. So, while the plasma flares created on stars fall back into the star or jet off into space, the ergosphere of a rotating black hole would mean a falling jet of plasma could acquire negative energy, while its corresponding escaping jet gains additional energy, effectively from the black hole itself, he said. This new study challenges a 1977 theory for extracting energy from black holes proposed by astrophysicists Roger Blandford and Robin Nyack. They suggested that magnetic fields near a spinning black hole don't reconnect, but instead generate additional angular momentum in the escaping plasma jet, a type of electromagnetic torque. So, both the new theory and the Blandford-Nyack theory could now be tested to determine which is the most effective for extracting energy from a rotating black hole, Commisso said. In the future, people will do supercomputer simulations of both cases, and there could be a comparison, he said. But at the moment, it's not clear. So, whichever theory proves correct, it could help astronomers better estimate the spin rate of black holes and quantify the energy given off by plasma jets near their event horizons, and eventually locate alien civilizations hiding in the universe. And this is it for today, guys. What are your thoughts on today's video? Share your views with us in the comments below. Also, don't forget to give this video a thumbs up, subscribe to the channel, and ring the bell icon for more amazing videos about space. And thank you for watching.